G'day Year 9s. Today we're going to continue with Chapter 3 looking at trigonometry. Last time we introduced ourselves to trigonometry. We learned about the three trig ratios, sine, cosine and tangent, as well as the other three less commonly known, cosecant, secant and cotangent. Today we're going to look at what we can do to use those to help solve problems to do with triangles. Let's have a look and see what we're doing today. So I've lumped 3F and 3G together for a good reason, because you're doing the same thing each time. It's the one concept. They just separated it into two different sections, easy ones and what they consider hard ones. I think of them as easy version 1 and easy version 2, and I'm sure after you've seen a few, you'll be thinking the same thing. All we're going to be looking at is what are the steps involved in solving a triangle to find a side using trigonometry. And there are only a few steps, and they're all pretty straightforward. And our first step is always labeling the sides. That's really important. Depending on the angle we're given, we've got to label the sides. The second step is selecting the correct ratio that's going to be useful for us. Oh, come on, little pen. Well, I can see it writing, but nothing's happening. I'm going to pause and see if I can fix that. Well, it didn't like something there, but I've managed to get it working again. So the second thing we need to do after labeling the sides is to choose the correct ratio. What's the little word we use to help us determine the correct ratio? I'm sure you're all saying it to yourselves at home. SOHCAHTOA. Once we've identified that, we then write the equation and solve. Oh, it's trying to misbehave again. I think my computer's getting tired. The third step, of course, is to write out the equation. Once you know which ratio you're going to use, we write it out. And the fourth step is to actually solve the equation. Now, before we can do that, we need to make sure we know how to use our calculators to evaluate values for sine. So I've got a calculator here. I'm going to have to zoom in again. Hopefully that way I'll be able to see. Yeah, I can see something on there, so hopefully you'll be able to as well. So when I want to do sine 50, before we do anything else, you want to make sure you're in degrees mode. Now, it says up the top of mine, oh, it's a little bit blurry there, but up the top there, you'll see it says deg for degrees. It's probably a bit too much glare there for you to really make that out. If you need to change, depending on your calculator, there might be a number of different ways you can do it. This calculator, there's a DRG button just above my finger there. If I click on that, it will change from deg to rad, which stands for radians, and G grad, or gradians, but we need deg for degrees. Once you've got it in the right mode, if I want to calculate, for example, you can see on the left there, sine 50, all I need to do is press the sine button and type in 50, and then press equals. And the sine of 50 is 0.766. Approximately. You can see it goes on forever there. It's not an exact value, so we want to make sure when we're finding answers to these, we use our approximately equal to signs. Enough of seeing my unshaven face. Let's keep going and see how we went with this. It still doesn't want me to zoom in. I'm going to pause one last time. Oh, I'm saying one last time. We'll see if I was right. So sine of 50 we got was approximately equal to, it now doesn't want to draw again. Things are looking up. 0.766. Cosine of 16, so the same thing. I'm just going to press the cosine button, type in 16 on my calculator and hit equals, and I've got that's approximately equal to 0.961, and tan of 77 is approximately equal to 4.33. Well, I've gone to 3 decimal places. I'll do the same for that one. 4.331. Pretty straightforward there, I think. You've got a few to try there on the right. I'm not even going to bother doing those with you. I know you're going to be able to do them. You can look them up in the book if you're really in trouble. These are the more interesting things. How do I go about solving this equation? Find the value of x in the equation cosine of 20 equals x over 3. First one I'm going to do is show you where could this have come from. Well, here's a nice right-angled triangle with 20 degrees in one of the sides. Now, cosine, SOHCAHTOA, C-A-H, cosine equals adjacent over hypotenuse. The adjacent side must be the one they're looking for. That would be an x, and the hypotenuse would be 3. This would be a triangle that relates to that question, the cosine of 20 degrees. So I find my 20 degrees. If I label my sides, always label the hypotenuse first. That side is opposite the angle that I know. This side must be the adjacent. You can see that adjacent is the one I'm looking for. Hypotenuse is the one I know. So when I look at the word SOHCAHTOA, it's definitely cosine, the rule that I need to use for that one. Let's go ahead and solve it. If cosine of 20 equals x divided by 3, well, to get x on its own, the opposite of dividing by 3 is to multiply by 3. So I'm going to have 3 times cosine of 20 degrees equals x. So x is approximately equal to, and you just type 3 cos 20 on your calculator. 3 cos 20 equals, and I'm getting approximately 2.819. Now there were no units there. Does that seem reasonable? It's always a good idea to check if your answer is reasonable. It might be a clue that you're in the wrong mode on your calculator. Well, it's got to be less than 3. I know that. And it's going to be bigger than this opposite side, so it's probably got to be fairly close to 3, because it's going to be opposite an angle of 70 degrees. Yeah, I think that seems pretty good to me. There's one for you to try. I'm not going to say anything. Pause the video now, have a go at it, and then check you got your answer right in a second. And I got x is approximately equal to 3.21. I hope you had something similar. Let's have a look at the next one, the ones which they call hard, and I just call easy version number 2. Solve for x in the equation cosine of 35 equals 2 divided by x. Looks slightly different from the previous one. Here I had x in the numerator, now x is in the denominator. That's kind of annoying. We don't want to know what 1 over x is, we want to know what x is. So the first thing I'm going to do is multiply each side by x. So I'm going to have x cosine 35 equals 2. And now, of course, to get x on its own, the opposite of multiplying by cosine 35 is to divide by cosine 35. So the exact value there would be 2 divided by cosine 35. But we'll also probably expect an approximately equal to, oh look, it said 2 decimal places. Did it say it in the previous one? It did, look at that, and I didn't even write it. So I could say equals 2.82 to 2 decimal places. Always important to read your questions. I did a good example there of showing you how easy it is to sometimes not remember. But if you do it in an exam and then you see it later on, go back and check. You never know. You might identify a mark that you could have given away. Anyway, 2 divided by cosine of 35. Push buttons on my calculator, and it's giving me approximately 2.44. That's all there is to it. So when the value you're looking for is in the denominator, you need to multiply by that thing first, get it out of the denominator, and then solve the equation from there. There's one for you to try. Again, pause the video, give it a go now. And there we have it. You get x is approximately equal to 3.397, rounding that to 2 decimal places. 7 is going to make the 9 go up, which is going to make the 3 go up, so you're going to get 3.40 to 2 decimal places. Hopefully you were A-OK with that. Well, we're going on for a while here. I bet at least I've been entertaining with the errors and glitches along the way. Let's have a look at this last couple now, and then we're going to leave you to get stuck into your work. You won't need many more examples than this. Here's one where I've got a triangle first. My first step, of course, label the sides. This is the hypotenuse. Here's the angle I've been given, so this must be the opposite side, which would leave this side being the adjacent. I need to identify the rule. What rule is it that involves the opposite side and the hypotenuse? Oh, that's sine, because it's SOHCAHTOA. Sine opposite over hypotenuse. That's the one we want. So I'm going to write out my rule. Sine 35 equals the opposite side 5 divided by the hypotenuse x. I don't like my x being on the bottom. Multiply through by x. I've got x sine 35 equals 5. So the exact value of x would be 5 divided by sine 35, but they've asked me to answer to 2 decimal places. And so I go ahead and do that now. 5 divided by sine 35 equals, and I'm getting 8.72 to 2 decimal places. You know what? I think you're going to be fine from there. You've seen enough examples. There are 3 more there for you to work through. please don't forget, quick points, really important to practice those skills from term 1. Keep it up. What else we got here? There are the questions for you to tackle. Don't feel like you have to tackle them all at once. I've got some upgrade activities in. This time there's somewhere for you to collect them. No bonus upgrade yet. Maybe there will be by the time you get to it. And once you've finished the little work for that section, please click on the form, fill in and let us know how you were going with it, how you found it. All right, best of luck. Catch you in the next lesson. We will see you for now. Bye.